So now that I've hopefully convinced you that entanglement-based networks are valuable and interesting, why should you start building them now? Why should you be interested in this right now? And why not wait until somebody else builds it? I would argue, and we at Aliro would argue, that there are so many benefits to starting now. And a lot of them boil down to the opportunities for collaboration, the additional time that you have, and the availability of resources right now. So for starters, working on things right now in a collaborative way enables you to lower your research and development costs. A pool of shared resources will lower the costs of implementing things, and you can get the benefit of resources shared across multiple departments while things are still in their nascent stage. Next, there's research and development security. You can perform secure testing in closed private environments because you can build these things privately right now and start figuring them out. Next, you can increase your research and development velocity by accessing pre-built resources. And this really lowers the barriers to entry and increases the speed of implementation because you don't need to build everything from scratch. Software people can make software and hardware people can make hardware, and no one needs to be wasting time reinventing the wheel if we do this in a really collaborative way. Next, there's the system level research and development. This ties really well into the previous point. We're at the point in the game where large organizations and governments, and even some smaller organizations, can start conducting this system level research because there are so many companies creating individual components and so many academic groups as well. So there's a lot of different technologies that already exist, and you can investigate how they'll fit together. So we are not too early to be thinking about things in this way. We're past the academic curiosity stage and into the stage where plugging things in and thinking about how they'll plug in is really vital and timely. Next, there's the issue of global competitiveness. So every tech industry has some dimension to it that feels like a race and a competition, but quantum computing is an extreme example of this, and quantum networking especially. I see a lot of parallels between quantum networking and the space race of the past because it will so profoundly change companies and countries' ability to protect themselves and effectively use resources, all kinds of things, that if certain groups unlock this technology before others, there will be very tangible benefits to that and tangible advantages. So this is another reason to start investing in this technology sooner rather than later, because there's really no substitute in competitiveness for getting an early start. And if you wait until other groups have already got this rolled out, it will be too late to protect yourselves from their advantages, but also too late to reap any of those advantages yourselves. Next, a real benefit of getting started now is that you have time to evaluate real-world use cases. So just like in machine learning, quantum networking is figuring out how to do really cool things, and people are excited about it. But it's one thing to have a cool, powerful technology, and it's another thing to apply it in a way that is really practical and useful and has a good business case or a good value to your citizens in the real world within an organization. So this takes time, especially if your organization is large. It takes time to figure out what the right use case is, fine tune it, and integrate it into your procedures that you do as an organization. So if you get started on quantum networking technology sooner rather than later, you'll have time to explore this and roll it out in a way that makes sense in a practical way, not just a, oh, that's cool way, and then you're trying to figure out how to really get useful value from it. Next, you can evaluate the technology if you start now. There are so many new prototypes that are being created, and they need to be tested together and they need to be evaluated because there's so many different devices, like say an entangled photon source. And they all have slightly different ways of being built, slightly different performance. And it's really helpful to be able to look at this big marketplace and figure out which components are going to be useful for your applications and which components you need together. So with getting started right now, you can evaluate all this functionality and security and performance and interoperability without being in a crazy rush to assemble things once the ship has already sailed and everything's available and other people have done it. Next, it's very helpful to start this journey right now because it fosters innovation. You can share facilities for research and collaborate and enable new quantum device capabilities by getting that innovation started right now. Everyone knows in a research organization, it helps to give training early on as opposed to later, because if you train at year one and then let those people work for 10 years, it'll be so much more fruitful than waiting until year 10 and then training more people and hoping that they can produce the same results in just a year. So time is such a key ingredient in innovation. And that's why we think you should be prioritizing it. And lastly, I think this is, again, very tied into the last one and very important, cultivating that internal familiarity within your organization. This takes time, and it's one thing to educate your workforce with the ideas, but it's something very different to give them practical hands-on experience and let them figure out what the pitfalls are and how to get around things. And there's just no substitute for time in this. And building things like test beds, which we'll talk about a lot more in a minute, really enable this kind of internal familiarity growing and flourishing.